Hi everyone, this is COVID, back with another episode of Beyond the Code by Typo. Today with us, we have a fascinating personality who is a technology leader, tech blogger, public speaker, and a technical architect. He has 25 years of experience in engineering and leadership, currently serving as a CPTO at xDesign, leading 250 plus engineers. He has great hunger for learning in technology. And I can surely say that because at this point of career, after 25 years, he has gone for a degree in cybersecurity and he is going for another degree in implementing AI. Happy to have you here, Jeff. Welcome to the show.
Thank you very much. I'm glad to be here, Covid. Yeah, you probably give me too much credit there. I think I've really enjoyed my career in tech. I think it's been hugely rewarding, and also subject as cybersecurity and artificial intelligence are so really of our time. I think it's really important to make sure that as somebody who sits in the exec space to really understand them as best as possible, really.
No, I think you deserve this. I'm sure people around you feel so. All right. So we'll get started on this. The first part is going to be a quick fireside chat where we're going to know more about Jeff personally rather than professionally. So are you ready for that?
Sure, yes. Looking forward to it.
Sure. So the first question. So I already know that you have a cat. Last time when we talked, she was also joining the call. I just wanted to know why cat, not a dog?
Oh, I think so. I love both cats and dogs. In fact, I've got a dog sat next to me here, just out of camera shot at the moment. So the cats are definitely not here because they're not really good friends at the moment. I've grown up with both of them, but cats certainly, I think they're quite independent. They've got a lot of personality. They knock everything off your desk. I think they were just very great fun to be around. I love both, but certainly for me, I just slightly prefer cats, but I'm trying not to make the dog jealous. I'm sure she's listening.
Amazing. So this is the next question. What was your first encounter with technology?
So yeah, I remember it really well, which is bizarre because I was around 6 years old, so I was quite young. And my father had just bought a Commodore VIC-20, which is an exceedingly old computer. It had 4 kilobytes of RAM. It had it couldn't support like things like sprites, and it just had a beeper for a sound chip. It was very, very basic and rudimentary. But that was my first real technology introduction. I mean, obviously we use other bits of technology in our everyday lives, but actually a bit that you could program and you could do things with. And I could put 10 print hello and 20 go to 10 and be amazed that you could do that. So that was my first, and that was what got me hooked, and I started learning to code pretty soon after that.
Oh, that's amazing. And that's quite old. Which year are we talking about here?
So this would be around maybe 1983, so a long time ago. I mean, it's a MOS 6502 processor running at point something of a megahertz. I mean, we're talking seriously primitive technology. Certainly never imagined that in my lifetime the entire way of living would change, because the internet, I think, has existed since the 50s in some respects, but the actual web, in my lifetime, seen it flourish and become our way of life. When I grew up, we didn't even have a telephone inside the house. We had a telephone box at the end of the street. To go from that to having always on instant communications throughout the entire world and this has all happened in my lifetime, which is absolutely crazy to me.
Yeah, of course. I mean, seeing this transition, I was not even born then. So you have seen technology since that time. Not to make you feel old at all. I'm sure you are younger at heart than me, of course. But this transition.
Nice save.
This transition from that point till today, I think you have seen a lot. I'm sure you have seen a lot.
And the thing is, looking at a little bit of a taste of what's happened this year with artificial intelligence, I don't think it's the last one of these we'll see. We'll see another great change in our lifetimes. Now, if I could predict that, then I would be the next Bill Gates or the next Steve Jobs. But I think there'll be another one or two. If you look at the industrial revolutions, they're getting shorter and closer together. So, the first one happened, I can't remember the exact date, some time ago. And then we've suddenly started squeezing together, and And when will we be seeing industry 4.0, 5.0? They're getting close together, and we will see these huge changes in how we live and how we think. Even AI and Google have already started to change how we think. They've done studies on things like neuroplasticity and seeing how people retrieve rather than store information. School used to be about learn loads of facts and cram it all in and keep it in there, and now it's like, how do you go and get information? So it's very exciting.
Actually,
it's a very exciting time to be alive.
All right, amazing. Moving on to the next one. I'm sure you're reading a lot of books. Which one's your last one? And share some learnings from there.
I buy far too many books, so I love to read, but also I buy more than I could possibly read. I think there's more than I could read in my lifetime. One of the last ones I read was Team Topologies. I'd been thinking for some time about how teams are formed and also how static they can be. And I think this backs up the idea of thinking about moving to more dynamic team structures, thinking about flipping Conway's law on its head, and thinking about actually designing your organization, and certainly within your digital arm, around what you want to achieve, rather than letting your systems end up being designed the other way around. And I think breaking down silos with siloed areas of the business, traditionally things like architecture was quite a siloed activity. I mean, once upon a time, QA was, security still is, and that's one of the big things I'm really, with my fellow podcast host, we're trying to break down those barriers. Every time it's like whack-a-mole. Every time we break a silo down in tech, there's another one somewhere as the tech world gets bigger and bigger. Right. So there's a lot of lessons like that in there. And things like around reducing cognitive load, because you want to be able to give people information and communication, but not too much because it becomes overbearing. Right. It's good to have a big organization and the support of a big organization, but sometimes it can be a bit of a blunderbuss of information. It's far too much.
Right. Makes sense. Cool. I think this is an amazing read for the audience as well.
It's quite short. It's quite a short book.
Okay.
So also, don't worry too much about the time investment. I think you'll take a lot from it quite quickly.
Cool. All right. So that was a nice fire chat with you. Now we are moving to the main section where we would want to learn from your experiences, from your success and failures, the challenges that you have had. We get on to that. I have a question from there. Last time when we were talking, you mentioned about your philosophy of the iron triangle. So I just wanted to know more, a deep dive on it, make the audience also learn the same aspects which you were mentioning. So can you just throw some light on that philosophy of yours?
Yeah. For the listener who's not maybe aware of the concept, it's an age-old project management concept of the iron triangle. Now, once upon a time, it used to be time, cost, and quality, but then people changed that to be time, cost, and scope. And the idea is you can choose two of them, but you can't have all three because you can't cross the triangle. Right. And you'd put quality in the middle and hopefully make that invariant, because really people usually don't want poor quality software. And the idea is, well, if it's going to be cheap and fast, then you need to lose scope. And if it's going to be cheap and have the scope, then maybe you'll just need to take longer because you'll need a smaller, more focused team, etc. Well, how do you beat the iron triangle? And in tech, I remember recently working on a system where we'll use containerized Java services for this a few years ago now. And we looked and went, but these services are really simple. Why not just use serverless tech and they make this as light as possible? And I went, oh, but we haven't done much of that before. Well, learning's fun. I personally did some of the first integration and went, oh, look, that took us from zero to actually working maybe a couple of hours. And really, if you were trying to build all that up and then put it all as infrastructure as code, etc., that would probably take days or weeks. And so it's using this technology smarter. I think that, in my opinion, is the key to beating the iron triangle in tech, is using smart technology. What that does is it gets you more from your time and your money without sacrificing scope at all. There's a set of scales here because you can just go, well, let's just use a no-code platform. And that's kind of okay for some things. So there are some, I'd say, back office applications where it's fine, possibly. But if this is a user-facing application, it might not be fine to use a no-code app because some of them don't necessarily have the most amazing user experiences. An ex-colleague of mine, he came up with the term lower code. So it's not just a low-code platform. And lower code is just like leveraging as much of cloud native as possible. and leaning into, well, what can, so something like Azure DevOps, Azure Functions, and making sure you use like the Azure database service, and like what can you use with the minimum amount of configuration, the minimum amount of boilerplate to get you to where you need to be securely and scalably. And if you can crack that, then those kind of services don't really put any restrictions on how you deploy them and how you use them compared to maybe a no-code platform.
Yeah.
So actually, this gives you all the flexibility of kind of coding it, but also a lot of the speed of not coding it, which I think is a
big advantage.
And we're starting to harness that appropriately.
Yeah.
And I think this is where consultancies really do help, because they know how to do this. But there's loads of people still hand-rolling loads of stuff and wasting a lot of time and money, I think.
I think it totally makes sense. And I think that's how you break the age-old iron triangle, and maybe just thinking out of the box, thinking about new technologies to be implemented. You can save a lot of time and maybe deliver fast and while it is cheap. So yeah, cool. I think that was really insightful. I have another aspect that I wanted to know, because you have been into leading teams and building things at such scale in organizations. So you and your team, of course, approach implementing the latest technologies that are involving security and AI. How does that work out right now?
I think there's a couple of things there. I think if we're talking about security tech or AI technologies, one of the key things for if you're going to take something into your organization is doing a proper technology diligence process. And that sounds awfully long and boring.
Yeah.
But actually, if you boil it down to what are the key things that matter to you, well, it'd be slightly different between, say, an open source project and maybe a proprietary or a SaaS product. But for, say, like open source, well, how mature is this technology? How many people are contributing to it? When was the last major release? Is it actually, if you scan it, is it vulnerable or not? Is it still in good use in the community? And going on to Stack Overflow and looking at how many Stack Overflow questions there are about it is a good yardstick for how popular something is. But it also, is it too mature? There's a point where Log4j became so old and long in the tooth that the creator of Log4j said, no, don't use that, use Logback instead. So it's that balance of looking at the maturity, the developer support as well. So it's no good procuring a technology if you have to train everybody to use it, really. It becomes then quite onerous task to actually upskill everybody on it. And then you have a problem that, well, how do you know best practice if nobody else knows it in the team? So choosing technology, I think, but when it comes to things like AI, there's a lot of it is around, well, what's this going to cost? Because AI is expensive to run quite often. And also, where's the data going? Because you probably, we're in GDPR countries, so you probably want to be sure that your data, you're not giving away personally identifiable information or clients or your own intellectual property, because it's not just the AI provider who might run away with that. They probably won't, if something like OpenAI would, but they themselves are subject to attack. They could be part of a supply chain attack. So your data may or may not be safe. So now safety is a kind of it's never 100%. There's no such thing as 100% security unless you turn off all your computers, seal them in 7 meters of reinforced concrete and dump them in the Mariana Trench. That's a particularly safe, that'll be secure, but it won't be very usable. So it's that trade-off of risk enabling innovation in that respect.
Yeah.
But things like if you're choosing AI tech, in the case of, do we have a UK data center? That makes things much easier. And if they're within a GDPR country, that makes just things way, way easier.
Yep. Yeah, definitely it does. So basically, whenever you are looking at implementing AI, there is definitely the aspect of security, which you're really emphasizing on. How exactly, when you take care of the security part along with it, is there a framework? Is there any steps or guidelines that we have to actually follow when we are implementing it? That would be my follow-up question there.
Yeah. So if you're using an AI to build it into a product, really, one thing about AI is it's really quite hard to secure the use of that AI if it's, say, like ChatGPT based, because people try and put in protections around it. But what you don't want to do is end up becoming effectively a free version of ChatGPT for people to abuse. So really, we recommend thinking about the design of the security from the very far left as possible, and that's at the product, when you're actually at a product and design space. Because it's really hard to, and it's expensive to fix fundamental security flaws when you all get all the way to like release. So you're thinking about, well, actually, how do you make this? And it's not just from a technical point of view, it's almost all from a, well, who might abuse this service point of view? We call it, there's something called persona non grata, and it's the opposite of the persona. You know, when you do product persona, it's the opposite. It's the people you don't want. They're the abusers. And then we put senders into misuse cases and abuser stories and link them to our security non-functional requirements. And when it comes to AI, it's really hard. It's like, well, what countermeasures do you put in place to stop people abusing it? But also there's obviously the other sides to AI. You know, people could try and do a model inversion attack. They might try and poison your model. They might use other adversarial AI attacks. So there's also the protections you need to put around that model to avoid it being unduly influenced. How do you kind of tear that model down? If you think your model's been poisoned, how do you tear it down and recreate it in a safe way? So you have to think about all of that before you build it all out. And the other thing is, like, they could effectively attack your infrastructure by overloading that AI, that model, or just blow your budget by spamming it with requests. So there's a lot of considerations. And the main thing is like putting in threat modeling to start with. And that can be product-based threat modeling through persona non grata, misuse cases, abuser stories, attack trees, and things like that. But then also, once you've got the basics there, move on to something like using something like Stride to actually do structured threat modeling. And then make sure you have a very robust way of managing your security threats and risks. And the other thing is, and make sure you have your entire development pipeline has got a really good automated security pipeline in place as well.
That sounds something like a good step-by-step advice for a lot of things while implementing AI and taking care of the security alongside. That's great. I think that really helps our audience learning more about it. Next question is, again, there are things apart from implementing technologies and delivering projects. We particularly look into the developer experience. When we are at this scale, we need to have a good culture in place. So when you try to make sure that your team is efficient, what kind of metrics you look at? How do you define success for a team? And when you identify problems in your team, how exactly you end up solving them? So you can just give some examples here that you would have seen at your organization or your previous organization.
So obviously there's old-fashioned, there's traditional, I think old-fashioned is too harsh, traditional metrics of things like velocity, but then you can start thinking about DORA metrics. And a lot of it is around, I think, helping people understand that lean and agile together. And nowadays we're implementing space metrics, which covers kind of quite a broad range of things. And I think it's really useful to look at where your pipeline stalls in your process and where there's waste in the process. So if something keeps going around the loop because it keeps failing, or you're getting a high defect injection rate, well, why is that? And it's not about blaming people. It's about figuring out what part of that process or culture is broken. Maybe things like staying in review for too long. Maybe things are taking too long to release. And quite often, for the most part, I'd say most teams do want to do a good job. It's just their environment around them is not allowing them to do so because it's inefficient in some way. It might be poor infrastructure, it might be poor release process, it might be tedious red tape, it might be over-the-wall mentality because you've got a separate team doing QA rather than bringing them together. So there's a whole raft of and it's measuring the waste. Basically, for the most part, it's measuring the time wasted because there's a gap in the process or because it hits the process and has to go back again. So any measurements like that, and obviously things like actual quality measurements, stuff that's relatively non-controversial, like Sonar Cloud coverage. Test coverage is a hot, it was a hot topic for a long time because people would try and get towards 100% coverage. But actually, if you just measure coverage, that's Goodhart's law. I think when a measurement becomes a target, it ceases to be a good measurement, and people would just fake tests to make 100% coverage. It's all about the actual quality of that coverage as well. And I don't think there's a shortcut to quality, but what you can do is try and bake it in as much as possible by measuring what you can in a sensible way. I think McKinsey drew a lot of ire from the industry by saying, you can measure developer productivity. And well, I think if you're measuring productivity in a way to actually help like remove blockers and build the ideal culture and efficient way of working, that's fine. If it's measuring productivity so you can shoot the bottom 10%, that's not fine at all. So I think that there's different ways of looking at that lens. And I think actually, if you take away the emotive aspects of what McKinsey published and then look at some of the areas they're looking at, like kind of the organizational maturity and their engineering maturity, and like, okay, so this is very sensible stuff to measure. And we've actually started building out all these measurements. We've been assessing our internal projects. And you find some really interesting things. You find improvements in where CI/CD can be made, and improvements where things like security champions can be the program can be improved. So I think when you start measuring, you have to understand that you'll probably find a lot of stuff. Then once you've measured, it's actually about prioritizing what's going to be the most impactful thing to change, because you might find 50 things, and which one of those is going to give you your best return on investment. And that's what you need to start evaluating and think, well, actually, this is costing us, we'll say 80 developer hours a week because it's really hitting the team. Like, well, this probably needs fixing. If this is an annoyance that's costing us half an hour every sprint, well, we can probably live with it. But also then there's the impact of other things as well. Security deficiencies may not actually have any actual productivity impact, but they sure will if you get fined because you've lost all your data, or your system goes down, or all your data is stolen.
So this is something which would really help in identifying the inefficiencies or the bottlenecks in the whole software delivery pipeline. I would like to also emphasize on the point where you define the success for your engineering. Of course, these metrics are something which would give you symptoms or would tell you problems and where they exist. But ultimately, this is again a generic as well as a personal opinion that for engineering teams, there should be certain goals, how we define success for them. So how do you see that success? I would be interested, and the audience would definitely be interested in knowing that.
Yeah. So again, I don't think it's around age-old thing of how many lines of code have you delivered. I think it's more about for me, it's reducing cycle times and increasing the quality of builds, reducing failures, reducing the wastes. So you should be aiming towards, well, what's our effective, what's our uptime of our builds? Right. And incentivizing on things like that, incentivizing on quality going up. The measurement should be, if you're improving quality, then you are being a good citizen. If you are leaving the campground in a better state than you come along, you are being a good citizen. That should be, acknowledged. It should be, people should
rewarded for that.
Celebrate that people have taken an interest in quality. And then there should also be notifications if there are problems, if the quality is dropping, if cycle times are getting longer, because sometimes it might just be, well, actually we need to fix our build process because our build process is taking too long. I've had that in the past where people going, our productivity is awful because our build process is too long. We found some ways of parallelizing pieces. We took the build down from half an hour or 40 minutes to about 4 minutes. And that's not about anybody being non-productive. It's just about, unfortunately, over time things change. But if you're measuring that and you understand where's the waste in the system and set targets for people, if they're not meeting the target, it's not there to beat them over the head with a stick. It's like, what's preventing you from hitting these targets?
Absolutely. So in an organization where you have 250 plus engineers, how do you measure it? How do you ensure, is it done through processes? And then how do you ensure that the process is followed, or you use some tooling around it? So I would like to understand that as well.
So there's a mixture, and because we're a consultancy, so actually we use a number of different tech stacks. In some ways it'd be harder if we had nearly 300 engineers to measure in one giant team, but also in some ways it's easier because the individual engineering managers can see at their smaller level. So currently it's a mixture of, we take metrics from things like the build systems we're using, the CI/CD we're using, on things like Jira, and also then there's elements of kind of manual inspection around. Basically, we have an engineering maturity frame where we come in and kind of lift the lid on each project on a rotation. I think moving towards a more holistic dashboard and I think this will be even more useful for product companies, even more so for like product companies where they have very large engineering teams all working towards the same kind of goals, the same kind of metrics, is having a metrics platform where you can actually see, what does your build stability look like? What does your throughput look like? What does your waste look like? We've come a long way in these platforms in the last few years, but I think there's still room for challenges and still room for new innovation in that, because I think there are ideas of metrics also evolving as well. And a lot of companies still haven't adopted any at all. Or if they do, they're the most rudimentary ones. Obviously, as the industry becomes more continues to grow and becomes quite cost conscious, I think it will be a growth area.
Thanks a lot for this insight. And the one last thing, which is definitely of your interest, which is psychology. So you mentioned that you are into psychology and understanding the psychology of a programmer particularly. So how your understanding of a psychology of a programmer has helped you lead at the organizations?
So yeah, first of all, you can't completely 100% put people in one box, but there's a good chunk of us got into software for one type of reason, and some for another. But a lot of us got into it because we enjoy solving problems and we enjoy learning, and we enjoy the challenge of it all rather than just the money. And I think when it comes to, and this is backed up by research, and we're like, what do developers want? And I broke it into several key themes. And there's enablement, like people who are very smart like to be able to work creatively. I think there's a misconception that developers aren't creative. And I think it's just not maybe splashing paint on the walls or making music. It's a different kind of symphony. It's a symphony of code. So it's enablement, like giving them the tech and the tools and the autonomy to actually build and problem solve. And there's the excitement as well. Developers work so much better, in my opinion, and from my experience, when they bought into the vision of what they're building. I think so 20 or something years ago, it really was kind of, well, we'll pay you some money, build some stuff. And a lot of it was back-end stuff, not so much web stuff. But the modern graduate and the modern younger developer really do care about the ethics and the company ethos and culture of what they're building and where they're working. So really, having a really, really clear set of values is really important to the modern generation of developers. And then there's also the kind of engagement as well. As engineers are thinkers, they like to be engaged. They like to have their opinion heard and to also see that people act on that opinion. It's no good asking for feedback if you then just discard the feedback. So it's that kind of three things of enable, excite, and engage. And there's a number of different topics under there. And almost none of them really mention money. And people will stay somewhere if they feel all of those three factors, if they feel that they're excited and enabled and engaged. And it goes back to some of the measurements as well. If you actually start to reduce the wastes in the system, produce enablement, and allow people to work super efficiently with modern tech, then actually people will stay, even if they can see a higher salary somewhere else.
Yeah. I think this all brings it back to the point where you have to have a good understanding of who your audience is. And when you're leading a dev team, the developers are your audience and you have to build an experience for them. And it totally makes sense to understand their psychology and then build around it.
Well, there's a whole field of developer user experience. People go, oh, user experience, you think about the end customer. Like actually there is another user, and that user is often the developer or the other people in the team as well.
Yeah.
The team is having an experience at the same time, and you neglect that at your peril.
Yes, absolutely. Great, Jeff. I think that was really, really insightful and great talking to you. Any parting words for our audience?
I think whenever you're next looking at doing something new, think about how you could be doing it smarter, because you can't beat the iron triangle any other way, in my opinion. Just think about doing things smarter.
Amazing. Perfect. Thank you, Jeff.
Thank you
so
very much for having me today. It's been wonderful.
It's our pleasure. All right. See you. Bye-bye.
Bye.